All right, I have started the recorder. We are still about 10 seconds away from 9 o'clock, but I couldn't make it to Monday's lecture because I had an appointment in Davis, a dental appointment that was supposed to be a lot longer. And then the dentist found out that, I could not get a crown done because, there's too much infection. So I have to get a root canal instead. So that appointment was cut really short, but then I have to get a root canal done in the next 2 weeks or so. Fun stuff, fun stuff. All right, well, it is 9 o'clock. I'm going to get started. The recorder is on. I just checked, the audio is good, and then the recording is good too. So we have a homework assignment. I'm giving you a new homework assignment today. It is on sorted array search. So when you click on that, it will give you all the instructions that you need. So in this case, it is also going to be done using Google Sheets. You have to make sure that you share it with me with edit permission. So I need to have the edit permission. So in this one, you're going to use your student ID to initialize an array that is the starting point of the assignment. So in my case, because my ID is 00068887, so you need to make sure the array is sorted in a non-decreasing order. So in my case, it would be 00068788 because it has to be sorted. So we're doing okay so far with this part. Okay, your 7-digit student ID will be used to initialize a 7-element array called A. So we also have to find a particular digit that is not in your student ID to look for. So it's up to you to determine which one you want to use. So in my case, because 1, 2, 3, 4, 5, or 9 are not a part of my ID, I can choose any one of these as the value of V in the search algorithm. And then after that, you basically rename sheet one of the spreadsheet to lane search for linear search. The algorithm you need to follow is not the usual linear search. It is the linear search algorithm, but optimized for sorted array. So if you click on this link, it will bring you to the algorithm itself. Okay, it's not there. So it's supposed to be bringing you to here. This is supposed to be the algorithm. So I have to figure out, how to uh, make an anchor, out of HTML. But anyway, this is the algorithm. This is the improved linear search algorithm, and this is the one that you need to follow in the first trace. So do we have any questions about what you need to do in the first trace? Are we good? All right. So your second trace is going to be on a separate sheet. It's called bin search. So with this one, you have to use the binary search algorithm, and I know this one, definitely works because there's actually an anchor here. So this one is the binary search algorithm that we talked about on Monday. Well, I shouldn't say we because I talked about it on Monday on the YouTube video that I have released. So, do you all know where to find the video recordings? Okay, all right. So this is the second algorithm. So basically the same thing, in your sheet here, just do the trace. An example of the binary search algorithm is already posted, based on Monday's or the video recording that I released on Monday or the day before. So you can use that as a starting point to basically try to understand the algorithm and what you need to do in the trace so that you can show me that you know how to trace the algorithm. So do we have any questions about this assignment? You have 1 week to work on it. I don't think it's going to take you a lot of time, okay? If you already understand the algorithm and you have already watched the video on both of the enhanced linear search algorithm and also the binary search algorithm, it really is not really that much more complicated. It might take you one or two more iterations through the loops to conclude the algorithm, but other than that, it should not be very difficult. All right, so that's your assignment. It's due next Wednesday before the class starts. Are we okay? Are we good with that? All right. So now we're going to move on to a completely new topic, new and exciting stuff. So this time we're going to move on to, let me close the ones that I don't need anymore. So this time we're going to move on to, finally, subroutines or functions. So this is a new module that we are going to work on. And we are going to talk about functions or subroutines for a while because there are quite a few concepts that we have to go over when it comes down to subroutines or functions. So that's a new thing, and I highly encourage everybody to read the module ahead of time before coming to class because some of these concepts can be a little bit on the abstract side for people who have not done any programming before. If you have some programming experience before, this may not be too difficult. All right. So do we have any questions before we get started with subroutines or otherwise known as functions? No questions? All righty. All right, so we're going to get started with this one. So in programming, copy and paste is not a good approach to quote unquote reusing code. There are several reasons. The first reason is it is not space efficient. In other words, if you copy and paste a chunk of code, that means you have several copies of the same chunk of code, and as a result, um, you are going to use up your additional space for the program, because there are duplicate portions of the program. But this is not even the main reason why we do not want to copy and paste, because in modern day computers, your hard drives are now measured in terabytes, right? Your RAM is measured in at least 16 to 32 gigabytes. So you do have plenty of computational resources for ordinary programs. So the approach of copy and paste is not going to be a big deal, okay? If you need to if you have a larger program to put into your computer, it's not really that big of a deal. So the main problem of copy and paste is the code that you copy and paste may be flawed. In other words, you did not discover the code that has a problem before you paste it multiple times in your program. So now, a few days later, you find out that the original code that you copied all over the place was flawed. So what do you have to do? Fix them all, right? So are you sure you can find them all? That is the question. Okay, because you have sprinkled copies of a piece of code that is flawed or has a bug in it. So now the question is, can you find all the pasted copies of that piece of code and fix every single one of them? First of all, it is tedious. If you don't have to do it, why do you want to do it this way? That's the first issue. The second one is sometimes you may not find all the copies. So that means that you might still have a few of the flawed copy of the code floating around in your code, and they're just lurking around, and your program is just not going to work when your program step on those pieces of code. So am I explaining the reason why copy and paste is not a good approach in programming? So we good? All right. So that is applicable regardless of the class. Okay. So in this class, in CISP 360, 400, 430, even 310, okay, even in assembly language programming, if you have to copy and paste, you really have to ask yourself, do I have to copy and paste? There are some cases where you cannot avoid it, okay, but there are many other cases where it can be avoided. So what we'll do now is we're going to take a look at a particular program. It's called the main function. So this is the first time we introduce the concept of a function. So we'll go ahead and go a little bit slower and just to talk about what is quote unquote the main function. So as it turns out, if you want to write any C++ program, if all the code, okay, all the logic that you want to specify, they all have to be inside a function of some kind. That means all the programs that we have been exploring in this class, they will not compile. None of them will compile. because we have not introduced the concept of a function. So none of the code that we have talked about is living inside a function, but in C++, you can only have code residing inside a function. Code cannot exist outside of a function. So that is a big deviation compared to many other programming languages. So for those of you who know Python or JavaScript or anything like that, you would go like, oh, but I can write code without a function. It just kind of execute a code in a text file. Yes. Okay, that is true for most scripting languages. JavaScript is a scripting language. Um, Python is a scripting language. C++ is not a scripting language. So in C++, you can only contain the code that you want to execute has to be inside a function of some kind. So we'll take a look at a very special function. In this case, it's called the main function. It really is just called the main function. So the main function must have a name of main. Okay, it cannot be anything else. And the way we define the main function is typically like this. Okay, it starts with int, which means it has a return type of integer. That's something that we'll talk about later on. Okay, because it's a more advanced topic. And then the name of the function that we're defining is right here. The parentheses are mandatory. Okay, so the parentheses are here so that when we talk about parameters, the parameters will go inside the parentheses here. But because we're just starting out, I'm not going to talk about parameters. But in order to define the main function, I have to give it like an empty list of parameters. So it's just open paren and then close paren. The body of the function is basically the block statement that is right after the close parenthesis. So that means this entire portion, let me see if I can highlight the portion that I need to highlight. There we go. So this portion, which is starting with the open brace, closing with the close brace, that is a block statement. But the body of a function must be a block statement, cannot be anything else. So that's the basic syntax of the function of a function definition. And then inside the main function at this point, we are just going to say, okay, we must end with return zero. In other words, return zero is just a statement that we have to use. The explanation is down here. Okay, so the explanation of why we need a return zero is when your program is done running, it will go back to the operating system. Control will be back to the operating system. So if your operating system says, okay, I need to know whether the program terminates normally or is there anything wrong or anything that I need to know about, that is what the return value is going to indicate. Zero is by default, the indicator of everything is good, there's no problem. Okay. But if you return anything other than a zero, the operating system will basically go like, okay, something is not right, okay, about the termination of this program. Should I pay attention to it? So it can choose whether to pay attention to it or not, depending on the actual value that you're returning from main. All right, so I know that's a lot of concept, okay, but right now we just have to say, okay, this is how the main function is supposed to be, and everything that you do has to go between what we see as line 1 and line 2 here. Okay, so all the stuff that we have been trying to do, they have to go between line 1 and line 2. So do we have any questions about this? Are we good so far? All right. So what I'll do, okay, this is something that I'm going to do today because I want to illustrate, how a C program runs, just so that for those of you who want to give it a try, you can actually experiment now. Um, Instead of using Replit, I'm using online GDB. So there is a website called onlinegdb.com. So just go there and it will give you an interface like this, okay? And it will give you some advertisement, but you can just kind of ignore the advertisement. You can close the ad. All right, so this is online GDB. And you can see that, it gives you a, kind of like a default program in this case. Don't worry about what pound include is doing over here. Don't worry about what is printf doing here, but you can definitely tell that int main open and close paren is here. The block statement is here, and so it's returned 0. Okay, so we can actually run this program. When we run this program, it doesn't do anything other than just printing hello world. So it's not very exciting, but we can certainly just give it a try. Okay, so we'll move this up here, and it is complaining. Oh, that's just your advertisement too. All right, so we're gonna run it. Okay, so we'll go ahead and say run. Oh, I have to choose the language. It's just regular C++. All right, so this is the result of running the program. It just prints hello world, and it is all done. Okay, because I didn't specify to do anything else. Are we okay so far with this program? Okay, so this is not particularly useful. It doesn't really resemble things that we have done in this class. So instead of doing this, let's go ahead and use something that we have already talked about. So we're going to say, okay, int x, so this is a local variable. We'll talk about local variables next time. Okay, but what I need to do, what I want to do, is to show you, how a loop works in this case, just so that we have an idea of, oh, okay, so all the stuff that we have talked about, if you put it inside a function, they will all work. Okay, so we'll initialize x to a value of, okay, let's say 5. Okay, we'll say while x is greater than 0, do inside whatever is inside the braces here. And the only thing we're going to do is to say x gets x minus 1. All right, so from line 14 to line, oh, okay, I got an extra close brace because it is automatic. So from line 14 to line 17, that should not be new to us. Is that correct? All right. So now what we're going to do is to say, okay, how does this code work? Does it give us a trace? The answer is no. Okay, it actually does not give you the same kind of trace that you have been doing in this class. So what it will do instead, if I don't do anything else and I just run this code, it won't give me any output whatsoever. So if I just say run, okay, this is the output of the program. It doesn't say anything. So in order to understand what is going on with this program, I will need to put a breakpoint here. Okay, so this is called a breakpoint. A breakpoint means when the program runs, it's going to stop right there. Okay, it will pause execution right there. So let me just go ahead and this time I use debug instead of run. If you debug, okay, so I already know how to use it, so it's not an issue. So I just run the code and start execution, click that, and now we are pausing here. The reason why I know it has paused is because there's a green rectangle surrounding the line that it is stopping or pausing on. Okay, so we know that the execution has now paused on that line. And then the other thing we can also see is over here, we can see variable x currently has a value of 32,767. That's because x is uninitialized. In other words, the reason why we put a question mark in a variable that has no given value is because it has an unknown value that can be anything. So in this case, okay, at this instant of time, it just so happens that x starts with a particular value of 32,767, which is essentially the question mark that we are trying to use to represent this. Like, we have no idea what is the initial value of x. This is a possibility. Is that okay? So another thing that is important is right now it is pausing on line 14, meaning that line 14 has not executed yet. Okay, so that means x equals to 5 has not executed yet. This is the 32,767 is the value of x before line 14 executes. Is that okay? Because otherwise it doesn't make sense because line 14 is clearly trying to change the value of x to 5. So in this case, we are not going to use continue because continue is going to execute the rest of the program with no pausing whatsoever. Instead, we are going to use either step over or step into, which makes no difference in this class at this point because we are not using functions. So we can use either one. Okay, I'm just going to use step over. So we're stepping over, and you can see how the value of x is now changed to 5. Okay, not unexpected. But you can also see that it doesn't tell you anything about the condition that we are evaluating. So you kind of have to track that in your own head. It's like, okay, x has a value of 5. 5 is greater than 0 is true. So that's why we're going to end up on line 16 when I step over again, like so. So now we are on line 16. But remember, if you see the green rectangle, it means we have not executed that line yet. So that means x still has a value of 5, but it will become a value of 4 after we do a step. So let's go ahead and do that. Step over, and you can see how two things happened in this process. First of all, x is now decremented from 5 to 4. But we also got back to line 15 because that's the behavior of a loop. Is that okay? In other words, we are basically quote unquote tracing the execution of a program, but without using a spreadsheet of, we are actually tracking everything. So now we can go over, again, like so, you can see how the value of x is decrementing. So now we are at the last iteration. So this is going to be the fun one because when we step over, x becomes 0. It goes back to line 15. 0 is not greater than 0, which means the condition of the loop is now false. So that means we're going to exit the loop and go to the return statement. So right here, that's exactly the behavior of this code here. So other than the syntax, okay, okay, we have no idea why we have line 13 here. Other than that, are we making a connection between what I just demonstrated to the topics that we have talked about before? Okay, we are all good. Are there any questions about how this little demonstration relates to the discussion of the assignment statement, the while statement, and also another condition, another um, assignment statement over here? Do we have any questions about those? Nope. All right, I'm not seeing any questions. So in without any questions, I'm gonna move forward. Okay, but I'm just trying to show you guys this is a good resource if you want to quote unquote run a program inside what we call a debugger. All right, and the website is just online GDB. All right, so without any questions at this point, we are going to move on to talk about something else. Okay, so the main function is basically entire explained at this point, entirely explained. So now we're going to move on to question, I mean, not question, topic or section number 4. All right, section number 4 is a program. Okay, we, in addition to the main function here, we also have a function called f. Okay, f does not do a single thing. It has no parameters because we haven't talked about parameters. And then the body of function f is also empty, which means it doesn't do a single thing. So the first thing we want to do, okay, is to kind of copy and paste this program into online GDB, just so that we can see what it is going to do step by step. Is that okay? All right, so we're going to do just that. Okay, so we're going to modify main and also, so I can change a few things. I don't need this anymore. Oh, I need to get out of the running mode. So I have to stop execution first. Okay, stop right there. And now I can go back and edit the code. So what we'll do is we're just going to edit the code. Okay, get rid of all this comment here. It's not really useful, kind of distracting. And then we'll take out all of this stuff here. So now we have kind of like a blank state again. So we're going to do this, go back to the first line, and then insert this definition here. I keep forgetting that it automatically give me the end brace. All right, so now this code is almost exactly the same as the other code that we are looking at here. Are we good so far? Good. All right. So now we want to take a look at, okay, in an actual execution of this program, what is this going to do? So before we do that, I'm going to explain line 6 and line 7. they are both called invocations of function f. Okay, an invocation means on line 6, the program is going to say, hey, do we have a function called f? And the computer says, yes, we do have a function called f. It is defined on line 1 and line 2. And then what the invocation is going to do is to say, okay, let's continue execution over there, okay, at the function called f. Now, function f doesn't do a single thing. So when we get to line 2, function f goes like, okay, I'm done because I have nothing to do. So the question is, where is it going to go back to? Where is it going to go when we are at the end of function f on line 2? Well, that depends on how we got there in the first place, right? So if we got there in the first place using line 6, then it has to go back to line 7 to continue the execution at what we call the caller. Is that okay? On the other hand, if we got to line 2, or if we got to function f because of line 7, then when f is done, it should go back to line 8 in main in order to continue execution, because otherwise it becomes an infinite loop. It will never exit. Does that make sense? Okay. So I think the best way to illustrate this is to run it, okay, just so that you can see it. So with this program, I am going to put a breakpoint on line 6. In other words, the program will pause execution on line 6, and then we can single step through so that you can actually see how the code works. So we'll go ahead and use debug again, and then we'll start execution right there. And you can see how now we have a green box around line 6, which means execution is paused right before line 6. Line 6 itself has not executed yet. So what do? Well, we're going to single step, but this time it is important to use step into, because step over is not going to show you, oh, we are going into function f and then we're coming back out. So this time we do have to use step into. In this class, if you want to be safe, just use step into all the time. Okay, that's just the safer one to use. So we use step into, and you can see now, oh, okay, we are now in function f. Function f actually has nothing to do, so that means we are now ready to go back to where we came from. So we came from line 6, but I don't want to go back to line 6, because if I go back to line 6, then we're going to call f again on line 6 and it's not going to end. So at this point in time, because I got here from line 6, when function f is done, it has to go to the line following line 6, which is line 7. So let me just kind of pause here and see if there are any questions about why the function should go back to line 7 in main, but not line 6 in main. Is that okay? Are we good? All right. Okay. So when we single step again, okay, so we use step into again. Now it goes back to line 7. So line 7 looks exactly the same as line 6, which means we're going to function f again, and then there's nothing to do. And where should I go back to this time? Line 8, that is correct. Yep. So not caring about how this is done, do we have any questions about what just happened? Just the behavior of the code, not so much how it gets the job done. No questions? All right. So can you guys think of something in real life that resembles the concept of a function? Like instructions that you would give to another person. No? Yes, go ahead. Yep, yep. So, telling someone to, get something and then bring you back. So you, as the quote unquote caller, you're just gonna sit around until that person brings you back, that something. But after the person brings you back that something, you can ask that person to do something else, right? Yep. So that's kind of, what a function is. All right. So with that all said, now we look into the mechanism of how it can get this done. In other words, okay, let me just run the whole thing again. So we'll go ahead and stop and start over. So stop right there, debug, basically just start the whole thing over and then do a start here. Going from line 6 to line 1/2 is easy, okay? Because line 6 says, hey, is there a function definition called f? Okay, that's an easy question to answer. Yes, we do have a function called f. It is defined on lines 1 and 2. So that's easy, right? Knowing where to go is easy. So we go there, okay, single step, step into. Now, the question is, I'm done, okay? Function f is done. So in your analogy, it's like telling someone to go get nothing from your car. Now the person has to, so the person is now at the car, right? It's like, okay, what's your name? Brian. So the person goes like, okay, Brian told me to go to his car and get nothing. So, and then what do you think that person is going to do? Carry that nothing back to you. So how does that person know where to find you? Hmm? So so the person that Brian tells to go get something will need to jot down first where Brian was in order to know where do I go back to in order to meet you to give you back that nothing. All right. So we need a mechanism to do exactly that in a computer. Okay. Basically, leaving behind a little note of, oh, where am I supposed to find Brian again when everything is done? All right. So that is the mechanism that allows a function, the called function is called a callee. That's what is allowing the callee, which in this case is function f, to know, oh, I'm supposed to go back to line 7 this time. Okay, because if I go back to line 6, it's not going to end. So I have to go back to line 7, the line that is following the invocation in the first place. So that's how we can go back to line 7. So when they get back to line 7, guess what? Brian says, go get nothing from me. Go get nothing from the car for me again, right? So it would go to the car, and then now this time, okay, so let's go ahead and trace into it, step into, and now this time it will have to go like, okay, where am I supposed to find Brian again? This is a separate piece of paper, okay? So the first little slip of paper is already lost. This is a second slip of paper that tells the person how to get back to you. All right. So and that is the reason why when we step into again, this time it knows not to go back to line 7, but to go to line 8. Because every single time we invoke or every single time we call a function, the caller is responsible to go like, hey, this is a little slip of paper. This is where I will be when you are done grabbing the item for me. Is that okay? Are we good? All right. Okay. So if the concepts are okay, then the trace is easier to explain and also easier to understand. So basically the trace is going to look like this. Okay. So this is a preliminary trace. So let me go ahead and display both the algorithm and the trace, side by side so that we can just kind of track down what is happening first. All right, so we're gonna stick this to the upper right corner, and then we'll take a look at the trace here, okay? So line 3, which is the entry point of main, is where we start everything. So in this class, this is significant, so we do want to, write down, okay, we start everything on line 3, because line 3 is the entry point of a special function called main. So that means every single C++ program is going to have a main function. Are we good with that concept? Because the main function is the entry point of the entire program. So after line 3, where do we go? Well, we go to line 4. So line 4 is the first invocation of the function f. So we go like, okay, that's where we go. After line 4, we go to line 1 because line 1 is the entry point of function f. Now, in the previous exercise of using online GDB, it doesn't stop on line 1 at all because there's nothing to do on line 1 from the debugger's perspective. So it doesn't really show us that it actually stopped there for a very brief moment. Are we still good? Okay. So now we go to line 2 because line 2 is whatever is following line 1. But line 2 is special too because line 2 is the closed brace corresponding to the open brace here, which means we have now reached the end of the definition of function f, which basically means, okay, what you just told me to do at the car, I'm done. Okay. And now the question is, I need to go back to Brian, right? So it needs a mechanism to know that, okay, where am I supposed to find Brian again after this? So magically, we'll just say magically for now. So magically, the called function or invoked function knows that, okay, I'm going to find Brian again, or I continue execution on line 5. The invocation was on line 4, but it knows to continue execution on line 5. So on line 5, it goes back, but then it has another call again of function f. So it goes back to line 1 again. Line 1 goes to line 2 again. But this time on line 2, it knows not to go back to line 5, but to go to the line following the invocation itself, which is line 6. So when we get to line 6, that's when you say go like, okay, if we get to return 0 in main, we are all done. Okay, we just go to post right away, and that concludes the execution of this program. So are we still doing okay so far? You're going from online GDB, which is kind of like a live demonstration, to a trace, so that you can actually tell me, you can show me that you know what the program is supposed to do. Are we still doing okay so far? Yes, go ahead. Well, it's up to you because because in that case, if line 2 is empty, it has nothing to do. So you can technically go from line 1 to line 3 right away, or you can go through line 2, which there's nothing to do either. So the trace that you turn in, that you submit or as an answer or as a homework assignment doesn't have to be very exact. It just has to convey enough so that I know that you know what the program is supposed to do. So I'm not going to be very, strict about, whether you say line 1, 2, and 3 or just 1, 3, both are okay. Yes, that becomes a problem because if you put, the function, both of the function calls on line 4, then we have to say, okay, then we have to indicate the column number because both calls are on line 4. So that means the first time it's going to return to the same line, which is line 4, but a different column number. So since we have not really talked about column numbers, so I always separate function calls on separate lines. Yep. hmm Not quite. So underneath, it doesn't really understand line numbers or column numbers. It understands quote unquote the return address. But that's a concept that I cannot really talk about in this class. You will encounter that concept in CISP 310, which is after 360. So there are certain mystery stuff in this class that I cannot fully explain because it's a little bit too involved to introduce those concepts in this class. hmm But that's a good question. All right. Do we have any questions about this? I would say more or less kind of a rough trace of what line numbers or what sequence, what is the sequence of the line numbers when we run this particular program? Do we have any questions about that? No questions? No questions? All right. So if there are no questions about this, then we are moving on to talk about, okay, exactly how are we supposed to trace this? And more importantly, what is the actual mechanism that we use in this class at least to keep track of where is the function supposed to return to? Where is the invoked or called function supposed to return to? So that introduces, some new concepts that we haven't really talked about before. So this is kind of important. I'm just double checking. I'm still recording, okay, just to make sure that we have a full recording of today's lecture. This is not one of those lectures where we are just extending on a really important concept, but the extension itself is a minor thing. This is actually pretty important, okay? So that's why, I really need to make sure that this lecture is getting recorded. All right, so we're going to start with this trace here. Um, Comments is now on the left-hand side, because the number of columns we need on the right-hand side is dynamic. So I can't put the comments column on the right-hand side anymore because it grows and then it shrinks and it grows and then shrinks. So that's why from here on the comments column is always going to be on the left-hand side, the leftmost side of the trace of the table. All right, so we'll go ahead. Okay, we always start with the pre, but this time I don't have any variables, right? I don't see any variables, any assignment statements anywhere in this program. So there's really nothing to say for the precondition. Okay, not a problem. Then we start execution on line 3. Okay, this is because line 3 is the entry point of main, and main is the first function gets quote unquote gets called. And then we get to line 4 only because line 4 is the first statement on inside the definition of main. So this is what we do. We invoke f, and we have to remember where to return to. So this is where we go dynamic. Okay, this is where we dynamically allocate the next column, and then we call that the return line number. Okay, so ret is return line number. So we basically say, okay, we need one more column now to remember where we're supposed to go back to when the called function is done. So let me just pause to see whether everybody understand the mechanism itself and also the rationale behind the mechanism, why we are doing this. Are both of those clear? The mechanism, we allocate, quote unquote, allocate the next column on the right-hand side, label it so that we know what we are using that column for, and then we write down the 5. So the 5, this 5 here, is corresponding to which line we're supposed to return to, which is line 5. That is the reason why we have a 5 here. Is that okay? We good? All right. So after this, okay, this is all done by main. So after doing all this, then we can continue execution on line 1 because line 1 is the entry point of function f. It is right here. Now, obviously, line 1 doesn't do a single thing, all right? And so, and line 2 does not do a single thing except that it is marking the end of the definition of function f. So that means when Brian tells the other person to go back to your car to do something, now the person is done. Okay, maybe to get something for you or turn off the headlight or whatever, right? So now that that person is done, the person goes like, okay, I still have Brian's key to his car. What am I going to do now? So at this point, the function, which is the person who's helping Brian, is going to look up the little slip of paper that Brian has prepared, which is, oh, meet me at the cafeteria. I will be at the cafeteria after you're done with turning off my headlights. Okay? So the function, which is the function being called, which is function f, now goes to the return line number. And what it's going to do is to say, okay, whatever this line number is going to be the next line number that I need to go to, which is basically the same thing as your helper looking at the little slip of paper and go like, okay, I'm going to meet with Brian again at the cafeteria to return the key. Is that okay? And so once we know where we need to go, that little slip of paper is not needed anymore. So we put it into the recycle bin. Okay. So when you see the struck through font corresponding to the heading or the description of a column, it means we are quote unquote deallocating that column. That column becomes available again. Are we okay with that concept? The column is no longer in use once we have a little struck out label saying that okay, whatever we used it for before, we're done with that use of this column. So the column becomes available again. Is that okay? All right. So we continue execution on line 5 because Brian wrote down, I will be in the cafeteria when you're done turning off my headlight. So now the helper goes back to the cafeteria and say, okay, Brian, these are your key. This is your key to the car. I'm done with this job. Okay. So what do we do on line 5? Well, you have another job for that person. So Brian goes like, hey, can you go back to the car? Because I think I forgot my computer in the car, or I forgot my cell phone in the car. So that person goes like, okay, cool, I can go back to the car. So, but this time you're gonna write on the same slip of paper. You erase whatever was on that original slip of paper, and then this time you go like, okay, when you are done, I will be in STEM 306. Okay, so the piece of paper has changed because you are going to a different location while the helper is going back to your car. So that is why when we invoke the function f again on line 5, we are now going like, okay, let's go back and reuse that little slip of paper that we had before. But this time, we are not going to say return when the function is done, go back to line 5. This time we have to go back to line 6, which is the line following line 5. Is that okay? So that's still Brian doing it, okay? The caller is responsible to allocate the new column. Well, but this is not a new column. We are reusing a column that was used before, but as far as we are concerned, we are reallocating without knowing whether the column was used before because we deallocated already. So we reallocate this particular column, and then we use that column to say, okay, when the function is done, it's supposed to continue execution on line 6. That is the job of the caller. In other words, it will still be part of the execution of line 5 that is setting up the return line number and also remembering the return line number. Okay, so we are still on line 5 at this point. After that is done, after we remember where we need to go back to, then we can continue execution at the function that is being called. In other words, the helper is now at your car. Okay, so this time they have to go get your cell phone, right? So when that is done, the person at Brian's car is going to go like, okay, I'm done with whatever I was supposed to do at the car. I need to go find Brian again. Where am I supposed to find Brian? Oh, right. He gave me a piece of paper to tell me where he will be when I'm done getting his cell phone from the car, right? So now the helper goes like, okay, cool. I will look up that little slip of paper which had the content of 6, which is STEM 306, right? So after that, the helper is going to go like, okay, now I'm heading to STEM 306. But at the same time, that little slip of paper is now useless. So that's why the helper or the function being called is the one that is responsible to deallocate the column itself to basically go like, okay, I have used the information on that slip of paper already. That little slip of paper is no longer useful to me. I put it into the recycle bin. I can use it again later on for whatever thing I need to use it for. So are we okay doing okay so far with those concepts? Yes. Okay, very good. So after that, the helper goes back according to the instruction here. So now the helper is meeting with Brian in STEM 306. And because there are no additional code after line 6, we have a return 0. So that concludes the execution of the entire program. All right, so let me just kind of take a short pause here to see if there are any questions about the mechanism and also the rationale behind the mechanism, because it is equally important to understand how we are tracing this, but it is also important to understand why we are doing this. Are we okay with this? All right. So if we're okay with this, I'm going to kind of give you a really short test of whether you understand this or not by changing this program to something a little bit different. Okay. So we'll go ahead and stop execution first. It's already stopped. So now we can go like, okay, let's make this program a little bit more interesting. So we have G here. Okay. So F is going to call G like so, and then we'll just go like, we'll also throw G in here. Okay, so this is our new program. This program will compile, it will run, and I want you guys to tell me the sequence of line numbers as it executes. Okay, so I'm going to open up a text editor next to it. Give me a second to get to Notepad or Mousepad. And then we are going to track down, what line numbers, or in what sequence are we going to go through those line numbers. So I will make this one always on top, like so. And so that we can still see the debugger, or at least, yeah, I don't really need to see the debugger, but it's okay. So we will put a breakpoint on somewhere else. So if you want to move a breakpoint, or if you want to cancel a breakpoint, just click on it. And then you just click on the left hand side of the line number that you want to put a breakpoint, like here, and it will put a breakpoint there. All right, so we have a new program, and we want to find out exactly what line numbers in what sequence we're going to go through. So let's go ahead and do this. All right, where do we start? Line 8. That is correct. So we start with line 8, and then we get to 9 is fine, but it doesn't stop on line 9, so we're gonna stop on line 10, okay? And then where do we go? Well, it's calling f. The question is, where is the definition of function f now? It has changed. Where do we go? Why would it go to 11? Not line 1, because we are still calling f here. So where is the definition of function f? Function f is on line 4, but you can say 4, but it doesn't really go to line 4, but we definitely will go to line 5, right? Line 4 it doesn't stop on line 4, because line 4 there's nothing to do on line 4, and therefore it cannot quote unquote stop there because there's nothing to do. So I will put 4 in parentheses, which means if you say line 4, I won't ding any points. Okay, it is okay, but we will definitely get to line 5. And on line 5, where are we going to go? We get to line 1. That is correct. So line 1 is once again in parentheses because it doesn't do anything. Then we get to line 2. Line 2 is the end of the definition of function g. So where is it going to go now? It will go back to line 6. That is correct. And then after line 6, where do we go? We get to line 11. And then after line 11, where do we go? Line 1 in parentheses. And then where do we go? Line 2, and then line 12. That is correct. Okay. So this is a quick test to see whether you are grasping the concept of calling and returning. Okay, it's kind of like a boomerang in a way. Okay, you throw the boomerang and it comes back to you, but it's not exactly that either, because you're basically you after you throw the boomerang, you're actually taking a step over. So the boomerang has to know that, oh, okay, I know that you're gonna take a step over on one side, so the boomerang cannot return to exactly the same location. All right, so what we'll do is to say, okay, let's double check that this is actually the behavior of this program when we execute it, when we run it. And I'm going to put line 8 also in parentheses, because we don't really stop at the beginning of a function. We stop only on a line that actually does something. So all the line numbers that have parentheses around is in the trace that we do in this class. I want you to include those, but when you're actually tracing it inside GDB, it won't do it. Okay. All right, so now that we have this, we can now say, let's go ahead and debug this program. And we want to move this up a little bit just so that I can click on the step into button. So we do a start first. There we go. and then we do a step into. So we are on line 10 right now, right? So right here. So we're supposed to go to line 5 next, step into, and we are on line 5 right now. So we are now over here, and then we are supposed to go to line 2 at this point, step into. We are now on line 2. Okay, so far so good. After line 2, it is supposed to go to line 6 because line 6 is right after the invocation that got us to function G to begin with. Okay, so that's why we're continuing onto line 6. So we go another step into, we get back to line 6. Line 6 is the end of the definition of function f, which means it is now the function f now has to ask, where am I supposed to go back to? Well, it's supposed to go back to line 11 because it was invoked on line 10. So function f has to return to line 11. Step into again, back to line 11. Now we are invoking G. The definition of G is on line 1 and line 2. So that's why when we go step into, it will go straight to line 2 because line 1 doesn't do anything. And then after line 2 is done, it is going back to the line following the invocation of G, which is on line 12, like so. And we are now at the end of the execution of the entire program. So are we good so far? Just in terms of the sequencing of the line numbers. We good? All right. So now we're going to go like, that's kind of interesting. So how do we trace this using the method that we have been talking about, using a table? Okay, because none of your test is going to be on a computer. I want you to tell me that you know the behavior of this program on paper using a table. Okay, so how do you show me that? So the answer is something like this. Okay, so I'm going to close this. Actually, I don't have to close it entirely. I just have to kind of minimize it like so. And then I will take a look at this code, just take a snapshot of this so I can display this on the side as I go through the trays. I didn't do a very good job grabbing the content. Let me do a slightly better job here. Okay, okay. This corner is probably a better way to start. Ah, my mouse button. There we go. Okay, just a little more. There we go. All right. So we'll show this on the upper right corner, like so. And now I can go to the shared folder to create a Google Sheets so you can follow along, if you have a computer in front of you or even a cell phone will work. So we're going to go ahead and create a Google Sheet, and it's going to be called with today's date 2025 10:08, I believe. Yep. All right. So we have comments all the way to the left now, okay? But I'm not going to use the comments, column in any way in this case. We have line number. So right now, only two columns are in use, okay? Because we don't know what the code is going to do. So we have precondition, which doesn't do a single thing. Then we get to main, which is on line 8, okay? And then we get to line 10. Line 9 doesn't do a single thing, so we don't have to trace line 9. If you put down line 9, I'm not gonna take any points off. But line 10 is special because line 10 is the invocation of a function, which means Brian is telling your helper, it's like, hey, I need you to go back to my car and grab something. But right away, you have to write down where your helper will be able to find you after your helper do whatever the helper needs to do at your car. So that means right now, I'm going to need to allocate a new column, which is column C. It is always going to be, whenever we allocate a new column, it is always going to be, now you might want to write this down or just kind of jot down the time. We always allocate the leftmost available column. Okay, I'll say that one more time. When we allocate, we always allocate the leftmost available column, which in this case is column C, because obviously column A is in use, column B is in use, column C is our leftmost available column to allocate. So now we allocate, we label the column according to what it is supposed to do, because later on we will realize that we allocate columns for a whole bunch of reasons. Return line number is just one of them. So we have to label this. Okay, I like to kind of boldface it. You don't have to. And then the column is going to be used to remember where the callee or the called function is supposed to return to, which in this case we line. Mm, no, the invocation is on line 10. So when the function is done, where is it supposed to go to? Line 11. Okay, so it's line 11 here. And after that, because we are basically saying, okay, when the helper is done grabbing something from the car, where are you going to be, right? So in this case, we are not going to be on line 5. We're going to be on line 11. Okay. So with this done, we can now go to the actual function being called, which is function f. Okay, so we go to the first line of the definition, which is line 4, and then we get to line 5 right away. And line 5 goes like, oh, we are calling a function again. What are we going to do when we call a function? Allocate a column so that we can remember where the called function is supposed to return to. And how do we allocate a column? We allocate the leftmost available column on the spreadsheet in the table, right? So you look at this and go like, column A is in use, column B is in use, column C is in use, okay? Because I don't see a struck out version of return line number. So column C is actually in use right now. So that means the leftmost available column is going to be column D. So now you do the same thing, label what this column is used for, and then you have to write down the return line number. Where is G supposed to return to when the invocation is on line 5? Yep, it's just line 6 here. There we go. And with that done, we can now continue execution where G is defined. G is defined on line 1, so we now continue execution on line 1. Line 1 doesn't do anything. Line 2, well, it doesn't do anything except it is the end of the definition of a subroutine, which means whoever is at the car is now going like, okay, I did what I was supposed to do at the car. I'm holding somebody else's car key. Where am I supposed to find the owner of the car key now, right? So what do? We do quote unquote the reverse. Okay, we try to locate the rightmost used column that is labeled return line number. Let me say that one more time. We go to the rightmost return line number that is not deallocated. So which one would that be? Okay, we have two columns labeled return line number right now. Column C and column D are both labeled return line number. Which one do we use? Okay, this is right, this is left. What did I say? The rightmost return line number that is still active. So which one is it? Column D, that is correct. Okay, so this is something that you might want to jot down after the class, okay, because I know it's hard to do it now, but if we always use the rightmost return line number column that is still active to tell us where we're supposed to go. Oh, we're supposed to go back to line 6. So the way we do this is we copy the 6 over here first to go like, okay, this is where we're going to find the owner of the car. Then we deallocate the column. In other words, at this point on line 2, we can go like, okay, this column is no longer used. And the way we indicate it is not going to be used anymore, or this is deallocated, is a strike through. Okay. On the keyboard in Google Sheets, strikeout, I believe, is Alt Shift 5. There we go. So Alt Shift 5 in Google Sheet will basically let you strike through the entire text that is selected. So now, at this point, okay, at this point in time, column D is now deallocated. It is not used anymore. Okay, so now we get back to line 6. What does line 6 have to do? Oh, line 6 is the end of another function. So what do? The same thing. We go to the rightmost return line number that is not deallocated. Can someone tell me which column is the exactly? Because column D is gone. Okay, so the rightmost column that is a return line number is now column C. So then we now go to column C and go like, hey, column C, why don't you tell me where I'm supposed to go to? Line 11. Okay, make a copy of line 11 over here to remind me that I need to go to line 11. But then that little slip of paper is no longer useful. So now I copy and paste it to here and say, yep, I don't need that piece of paper anymore. I don't need to hold on to it anymore because I just used the information to help me go back to where I'm supposed to go back to, which is on line 11. What does line 11 do? It's trying to invoke G now. Okay, so what do we do when we try to invoke a function? We have to allocate the we have to allocate the leftmost available column. Okay, and which column are we looking at now? The leftmost available column. Column C, that is correct. Because as we deallocate column D and column C, both of these columns are now available again. So when you look at all the quote unquote available columns, yeah, column D is available, but it's not the leftmost one. The leftmost available column is column C. So we reallocate column C and go like, okay, what are we going to use it for? Guess what? It's another return line number. So boldface it, and now we go like, okay, when G is done, okay, G is being invoked on line 11. When it is done, where do we want G to return to? Line 12, that is correct. Okay, so we put a 12 here, and now we can safely go continue our execution where G is located, which is just line 1, and then there's nothing to do. We get to line 2. Line 2 is the end of the definition of function G. So what is it going to do? If you say, I'm bored, is we are doing the same thing, this is the third time we are doing this, then congratulations, you're getting it. Okay, so what do we do? Exactly. We go to the rightmost return line number that is still active. So we go like, okay, we got return line number, we get return line number, we get return line number here. But you have to remember, we have to read it like sequentially. So at this point in time, the only return line number, the only column that is still a return line number is actually just column C, which is automatically the rightmost one. So we just go like, oh, okay, we're now using this column to tell us where we are supposed to go. Okay, copy that over here, and now we don't need that column anymore. So I'm just going to be lazy and copy and paste a return line number that's already struck out, put it here, and then we get to line 12. Line 12 is a return 0. So at this point of this class, we just go to post right away because I just mentioned earlier in today's class and go like, okay, return 0 is basically telling us that we're all done. Or I should say return 0 in main is telling us that everything is done. All right. So I'll be doing okay so far with all this stuff. Okay. So you probably need to write down, what I just said in the class, how to call and how to return. I believe those are all documented in the documentation in the reading material. So it's all kind of written down here as well. But these are words, okay? What we have done in the class is a live demonstration, so we can actually see the columns and see how we locate the columns. So I think it's equally important to read the instructions and also to watch the video that shows you exactly how everything is done. I mean, you only have to do it like a few times. I think some of you are already bored by going like, we're doing the same thing over and over again. Yes, that's what we have been doing. So are we doing okay so far with the concept of calling a function and then have the called function to understand where to go back to? All right. So you can do some more exercises on your own. Okay. Basically, you can kind of modify these programs a little bit and just make it a little bit more complicated if you want to. Okay. So the next question is can a function call itself? Okay, we got another 10 minutes. I can talk about that a little bit. The answer is yes, it can. Okay, but the question is, well, if it does call itself, when is it going to stop? Okay, so that's a good question. So I will address the first one first. Okay, in other words, I'll give you a program that quote unquote works in the sense that it will compile. We can trace through it a little bit, but then it's not going to stop. Okay, so we'll go ahead and talk about this. Okay, this is kind of important too. So once again, I'm going to change the program a little bit here. So this time I don't need G anymore. Okay, so we'll get rid of the function called G and just get rid of G entirely. Okay, I don't need that anymore. Instead, I'm going to have function f to call itself. That's it. This is the entire program. You go like, whoa, this is strange. Okay, can we really call a function from within itself? Let's go check it out. Okay, so first of all, I'm going to run this program or go through the debugger just so that you know that this is not a nice program. Okay, if you run it, it will basically give you what we call a segmentation fault, which means something bad happened. Okay, it's normal. This is perfectly normal. But we want to see how this program is going to trace. And we got about 10 minutes. That's more than enough time to kind of give you guys a quick trace of this so that you get an idea of what is going to happen when we have something like this. So we'll go ahead, get rid of this, and move this one in place. And then I'm going to open a new sheet over here to trace this rather strange looking program. So once again, we have comments, and I'm not going to put anything into that column. And then we have line number. We start with pre, which doesn't do a single thing, and then we get to line 5, then we get to line 6. Okay, so far so good, pretty easy peasy. So on line 6, we have to set up return line number because we are calling a function, and when the function f is done, it's supposed to go back to the next line. Oh, everything is off by 1. This is line 7, sorry, my bad. So the return line number is going to be line 8. Okay, no, not a big deal, just like last time. And then we continue execution at the function, which is on line 1. Line 1 doesn't do a single thing. On line 2, we're calling a function. So what do we do when we call a function? We we allocate the leftmost available column, label it return line number, and then on that column, we indicate when the called function is done, where it's supposed to go back to, right? Okay, so let's do that. Just because I'm calling f from inside f doesn't change what we have to do. It's exactly the same. So we have to allocate a new column, the leftmost available column, and then on that column we have to say, hey, when this called function, okay, because we don't even care who we are calling, we are just saying whatever function we're calling here, when you are done, you're supposed to return to the line following where the invocation is. The invocation is on line 2, which means the return line number should be line 3. Very good. Okay, so we just put a 3 here. This is totally legit. Okay, so we put a 3 here. I pressed the key 3 over here, so that's why I think it's zoomed in a little bit. That's okay. All right, and then where do we go after that? We go back to line 1. Very good. Okay. In other words, the mechanism of calling a function does not change in any way when you're calling a function from within itself. It's exactly the same. So we go back to line 1. It goes to line 2 because it's sequential. And then what do we do? Hmm? We do exactly the same thing, but we have to follow the instructions very carefully, right? So we have to allocate the leftmost available column, and which column would that be? Column E, very good. So we go to column E and go like, okay, you are the next available column. We label you return line number. And what do we put on that column? In other words, line 3 again, very good. So and then we go to the function that is being called. We're calling f, right? So where's the entry point of function f? Line 1 again. So you can see how this is going to go, right? We're just going to be allocating all the columns until we run out of columns. That is why in the debugger, so let me go back to the debugger. Where is it? Right here. So in the debugger, when we actually try to run this program, okay, using the debugger first is probably the best way to do it because then you can see that it will give you a segmentation fault. That is the cryptic message that you get whenever the processor is trying to go to a location that it's not supposed to go to, which is the side effect of running out of columns. Is that okay? All right. So we still have 5 more minutes. So I want to go back and talk about this program just a little bit. Okay. So it would seem awfully stupid to write something like this, right? The program does compile, it does behave in a certain way, but ultimately it's going to crash. Okay. Segmentation fault is basically a crash. So you go like, why would we do something like this? Well, that's only because we are calling f unconditionally. In other words, if we can do something like this, okay, so I'm not going to expand the program because I need parameters to explain this part here. So if I can do some kind of a conditional statement and say that only sometimes we are going to call function f from inside function f, aha, then everything changes, right? Because depending on the condition and the meaning of that condition, it means, oh, we are going to get to a certain point and then we're going to stop and then we're going to unroll everything. Okay. So this type of function is called a recursive definition. Okay. Or otherwise known as a recursion. So the value of a recursion is we have a lot of things that are quote unquote recursive in, I would say in nature, there's a whole lot of stuff that is recursive, but if you use a computer, you're dealing with stuff that is recursive too. So what exactly is recursive? What does it mean? You guys are looking at me, but instead you should be asking ChatGPT. Oh, by the way, you all have access to Gemini now for free. So if you go to your school account, okay, sign into apps.losrios.edu with your student ID and whatnot, then you can go to the URL, just type gemini.google.com, and now you have full access to Gemini. I believe it is the pro level of subscription, and it will be valid for the next 3 years. Now, I know most of you are thinking, I don't want to be here 3 years later, right? Because you only want to be here for 2 years. So for the entire duration that you're going to be here, you have a pro subscription to Gemini, which is kind of cool because now you can ask it stupid questions like, what is what is what does recursive mean? Whew, there you go. See, I don't need, you guys don't need a professor anymore. You just have to ask, yes. You actually can use the Pro too. The subscription itself is Pro, so you have, Flash, which is for general questions, but you can also use the reasoning model for math and code. Yeah, you do have access to both. All right, so recursive describes a process, rule, or definition that is repeated or applied to itself, etc., etc. Okay, that's actually an awful description. Recursive means self-similar patterns, which I guess is not much better. Okay, look at the tree. Okay, think of yourself as a squirrel. Okay, I think most people can think of that because we do have squirrels on this campus. So if think of yourself as a squirrel, and you are on a tree trunk here. Okay, all right. So and you need to go up. Okay, so a tree has branches, or most tree have branches. So if you're talking about a palm tree, kind of exception to the rule. Okay, so if you look at the oak tree particularly, it has a lot of branches, right? So the squirrel can go up and go to a particular branch, and guess what? That particular branch also branches off to even smaller branches, like this. Okay, the squirrel goes to one of those particular branch, and guess what? That also branches off to even more branches, and so on. So that means the branches of a tree is quote unquote a recursive construct because a larger branch has smaller branches, each smaller branch has even smaller branches, and so on. Each branch only end, okay, so if you keep tracking it down, it will end at a leaf, okay, Leaf, singular, okay. So even, but when you look at a leaf under a microscope, what do you see? More branches. Okay, so recursive is basically related to self-similar structures, which means when you look into a larger structure, you find smaller structures of the same nature. And you take a look at one of those smaller structures, and guess what you find? Even smaller structures, but also of the same nature, and so on. So that is the concept of recursive patterns. And recursive patterns is in it's basically everywhere in computer science. Okay, we have seen one recursive pattern already. The binary search algorithm is recursive. So we'll talk about that later. Yes. No, it is not. Yeah, that basically, okay, so when we look at this thing here, if we can specify a condition here to stop the recursion or to determine whether we should go for another recursive call or not, then it becomes a useful construct. Because as it was, it's not useful, right? The program just crashes. But there are many ways to change the algorithm so that it is actually useful. Yep. All right, so we're out of time. I know you guys have other classes to go to, so we'll continue to talk about this on Monday. So I will be here on Monday for the optional lecture. So this is one of those things where if you can be here in person, I think it'll be very helpful because you can ask questions interactively. Yep, yep. Have a nice weekend. Don't forget the homework.